Okay, this is May 2015, paper 1, time zone 2, question 8. It's an integration by substitution question. We're given the substitution in this case, and it's a slightly strange one. However, there's a bit of a clue about where we're aiming for in that arctan that we can see there. So that should give you a clue to keep an eye out for whatever arctan differentiates to. And in your formula booklet you can check that arctan differentiates to 1 over 1 plus x squared. So we're looking ultimately for something that looks like that. But it's a substitution, which means that we need to start by replacing replacing dx with dt. And simultaneously replacing the x's with t's. Now this first step, there's two ways to do it. You can start with t equals tan x, differentiate that, dt by dx is sec squared x. But then because we want to do the turning things x's into t's, at this point you're going to want to replace x's with t's. So you can rewrite sec squared x as 1 plus tan squared, or 1 plus t squared. If you do it the other way, to get to dx and turn it into dt's, you can start, instead of starting with t equals tan x, you can start with x equals arctan t, and if you differentiate that, you get dx by dt equals, like it's written in the red up the top here, 1 over 1 plus t squared. However you do it, you can conclude that you can replace the dx in your integral with the expression dt over 1 plus t squared. Now, that's not the hard work over, unfortunately. So we've got our integral dx over 1 plus sine squared x, and I can rewrite that as the integral of dt over 1 plus t squared all over 1 plus sine squared x. Problem comes is that I need to turn sine squared x into something involving tans, and that's not trivial. So what do we know about sine squared x? Well, one way to think about it is that sine squared x over cos squared x is equal to tan squared x. Another way to think about that is sine squared x times sec squared x is equal to tan squared x. And the reason I've written it like that is because I want to be able to rewrite everything in terms of t. Well, this is t, tan squared x, and we know there's a relationship between tan squared and sec squared. So I can rewrite this as sine squared x times, or sec squared, I've already said, is the same as 1 plus t squared is equal to t squared. And so that gives me my final form of what I'm going to rewrite sine squared as. Now, I'm interested to hear if anyone's got a faster way to get to that, because there's only one mark for it in the mark scheme, which I think is a little harsh. Now, once you've done that, you can rewrite your integral. So we've still got the dt over 1 plus t squared in the numerator, but in the denominator I've now got 1 plus t squared over 1 plus t squared. Now things are going to start, having got more and more complicated, things are going to start getting easier. I can times top and bottom by 1 plus t squared to get rid of the fractions within the fractions. And my integral turns into dt over 1 plus t squared plus t squared, or the integral of 1 over 1 plus 2t squared. Whew. And now we're very close to what the formula booklet gives us. So the formula booklet gives us, just as a quick reminder, that the integral of 1 over, what is it? Gives us 1 over a squared, right, 1 over a squared plus x squared equals, they're meant to be squareds, equals 1 over a arctan x over a. Finding it hard to write in that corner for some reason, but that's what it's supposed to be. A arctan squared. So if I can want to just try and manipulate that to being in this form, I need to take a factor of a half out. Take the half out, and I've got the integral of, so it's basically taking a factor of 2 out of the denominator, 1/2 plus t squared. If I want to rewrite it as squares, and you might be doing some of this in your head, but if you want to rewrite it as squares, that's the half of the integral of 1 over root 2 squared plus t squared, which means it's going to integrate to a half of arctan, I'm going to need more space, ignore that, I'm going to need more space, integrates to a half of the arc, so it's 1 over root 2, which in fact I'm going to rewrite as root 2 arctan x over 1 over root 2, so that's root 2 of t. And you'll remember from the very beginning, t was equal to tan x, so that gives me root 2 over 2 arctan times root 2 tan x plus c. That is a tough question. Anyone who can do that first go is doing very well in my book. Took me 8 minutes and 3 attempts.